So next we are going to learn about standard enthalpy of reaction. Enthalpy change, reaction or standard. Standard enthalpy of reaction. Standard enthalpy of a reaction is defined as enthalpy change for a reaction when all the reactants and the products are present in their standard states. Once more I'll repeat what is meant by standard enthalpy of reaction. Standard enthalpy of a reaction is the given in a book. Enthalpy change for a reaction when all the reactants and products are present in their standard states. Standard means I already told the superscript, this should be added to the symbol. What is standard enthalpy of a reaction? It is equal to the difference between the products and the reactants. Now I will give the formula for it. Delta H naught R, standard enthalpy change of a reaction, equal to summation of delta H naught R is equal to summation of delta H naught R products. R means reaction products minus summation of delta H naught R reactants. Products minus reactants. Consider a general reaction. A capital A plus B capital B giving C capital C plus D capital D. A plus B giving C plus this is a reaction. Small a, small b, small c, small d, these are all moles. This is the number of moles of the reactants. This is the number of moles of the products. So, how will you apply it in the formula? This formula. So, we will write now delta H naught R given as summation of products. This is the product. So, C means the mole into delta H naught formation. F, here also you can write formation. F capital C reactant plus small d moles delta H naught F. The C and D are the product minus now reactants, summation of the reactants. Small a delta H naught F reactant plus small b delta H naught F B. This is the formula used. Now we are going to work out one problem. I'll explain one problem, then you are going to do the other problem. See, here in your book it is given problem. The standard enthalpies of formation of C2H5OH L means liquid, CO2 gas and H2O liquid are the values minus 277, minus 393.5, minus 285.5 kilojoule per mole respectively. Calculate the standard enthalpy change for this reaction. Here the enthalpy change for the formation of O2 is considered as 0. Already I taught enthalpy standard heat of formation of all elements is assigned a value of 0. So this is assigned a value of 0. Now these are the reactant and this is the product. Now we are going to work out this problem. I will show how we are working out the problem. Now we are going to apply the formula. So this is the reaction C2H5OH liquid plus 3O2 gas giving 2CO2 gas plus 3H2O liquid. C2H5OH value minus 277. This is 0. Here CO2 value is minus 393.5. H2O value is minus 285.5 kilojoule per mole. Now we are going to apply the formula. So delta H naught RF is equal to delta H naught F of products minus delta H naught F of reactants. This is the formula. Now we are going to work out the formula. Here, this is the product. So, 2 carbon dioxide, 2 into delta H naught F of carbon dioxide plus next water molecule, 3 water molecules, so coefficient 3, delta H naught F of water minus here reactant side 1 mole of ethanol, so 1 into delta H naught F of C2H5OH plus 3O2, 3 into delta H naught F of O2 equal to, apply the value. So carbon dioxide value 2 into minus 393.5 plus 3 into water minus 285.5 minus reactants 1 into minus 277 into plus 3 into oxygen 0 by definition. So 2 into minus 393.5 is minus 787 minus multiplying this we are getting the value minus 865.5 minus product 1 into minus 277 minus 277 minus into minus becomes plus. So adding this one minus 1643.5 plus 277 subtracting 1366.5 kilojoule minus delta H naught F. This is the answer. Such a way how to work out. So, but the same method you work out this problem given in a book. Evaluate yourself how to work out this problem. Here H2 you take it as 0 because the formation of compound is 0, no? So you take this as 0 for others and all the values given here. Similar method you work out and send the answer to me for this one, children. Next, what is heat of combustion? Heat of combustion. Combustion means burning. So it is defined as the enthalpy change of a system when 1 mole of a substance completely burnt in excess of air or oxygen. Heat of combustion means defined as change in enthalpy of a system when 1 mole of a substance completely burnt in excess of oxygen or air, denoted by delta Hc. C means combustion, delta H means change in enthalpy. So always combustion reactions are always exothermic. There won't be endothermic, always exothermic. So the enthalpy change is always negative. Heat of combustion, for example, the heat of combustion of methane. You can see the book. See, methane, CH4 on burning with oxygen forming CO2 and water. The value, delta Hc value minus 87.78. One more example for the combustion of carbon. Carbon when burned with oxygen forming carbon dioxide, the value is minus 394.55 kilojoule per mole. Here also negative. So combustion reactions always carried out by negative value because they are all exothermic reactions.